Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student trying to find the zeros of a polynomial. So this is classic algebra 2. So I just started by rewriting the polynomial using x. It's just a lot easier to see it when it's written in x. Z is a little nasty. Now there's a theorem of rational zeros. It says all the rational zeros of this polynomial have to be factors of 6, the constant term divided by factors of the coefficient of the first term, which is 1. So we could be plus or minus 6 over 1, plus or minus 3 over 1, plus or minus 2 over 1, plus or minus 1 over 1. And when you have a long list like this and you're not allowed to use a calculator, well, you hope that 1 or negative 1 is going to work. And I tried 1 and you can see it does work. So that gives us a start here. And so now we're going to do synthetic division using 1 as our 0. And so I've got the original polynomial, which is 1, 1. We just write the coefficients. If you don't know synthetic division, you should probably look that up and find a lesson or two on that. But that's what we'll use here. So we bring down the 1 here, and 1 times 1 is 1. And then 1 plus 1 is 2, 2 times 1 is 2, 2 plus 1 is 3, 3 times 1 is 3, 3 plus 3 is 6, 6 times 1 is 6, and that gives us what we expect, which is a 0 remainder. Now we'll try plus or minus 2, and you can see that here now our p of x is just, this is called the reduced polynomial. This is going to be x cubed plus 2x squared plus 3x plus 6. I don't think p of 2 is going to work. Let's give it a try though. So that's going to give me 8 plus 8. You can see right away plus 6. They're all going to be positive. That's not going to be 0. Let's try p of negative 2. This might give me something. So this is negative 8 plus 8, because negative 2 squared is 4. 4 times 2 is 8. Make it negative 6 plus 6. So that's great. So we're getting a 0 here. So we'll just continue with our job of reducing the power each time with each of these zeros. So we'll put our 0 here, put up our starting point here, which is this reduced polynomial. So that's 1, 2, 3, 6. Bring down the 1. 1, 2, 3, 6. Bring down the 1. Negative 2. So that's 0, 0, 3, negative 6. And so that gives us another reduced polynomial. And this is going to be x squared plus 3 equals 0. And we'll finish this off. X squared equals negative 3. So x is going to be plus or minus I root 3. Okay. So there are two real answers, which would be they only want the real solutions, which is kind of a break for us. Usually they want all the solutions, real and imaginary. Let's just do that. So the real solutions would be comma separated lists. So this would be, what do we find, 1 and negative 2. If you wanted to write the imaginary. Not a very long list here. So it'll be I root 3 and negative I root 3 would be the imaginary zeros, and that's it. So it's a little hard to do without a calculator, but it can be done. It can be time consuming, but it can be done. So I hope this was helpful to you, and I'll see you again next time. Bye-bye.